Now I would like to show the model of the sprocket gear from the starting point. This is the dimension of sprocket gear and the geometry of the teeth. So it takes from the standard the edge of the upper the teeth because it has some engineering aspects calculation. Just the pitch is 19.05 millimeter, roll diameter 11.91 millimeter, width between inner plate is 12.57 millimeter, and pin diameter 5.94. We can take this geometry from the standard based upon the fitting chain standard 12A ISO. So by taking this, we are going to model the dimension of the sprocket gear from that. For example, the outer diameter of the sprocket gear is 198.1 millimeter and the inner diameter of radius of the gear is 92.05 millimeter. Let's get started. Okay, start mechanical design, part design. Let's start mechanical design, part design. Sprocket gear, the name of the part. Write it, sprocket gear. And okay, this is the new workbench display, and I have selected the plane that YZ plane. On this plane, then click on the circle, take it the outer circle, click on circle, take it the inner circle. The dimension of the outer circle is 198.1. Right dimension 198.1 and make it the radius of the inner circle is 92.05. So diameter 92.05 times 2 is equals 184.1 millimeter, and the arrangement of the teeth based on the standard is constructed on this element. For example, divide this element to this. This is the upper part, the lower part, and we construct the teeth based on the standard dimension. For example, I would like to designate just like this. This drawing is not based on the standard dimension of sprocket gear. So I have draw a line and I can mirror it based on this axis and mirror this line. No. Mirror this line based on this axis. It's constructed. So from this line, let's check it. This is the inner. This is the outer. So this is the outer. Construct this, and for example, I can draw it just like this. This is not based upon the standard. This is not based on the standard. So I can construct this like this and mirror this element on this axis. Okay, nice. So after that, let's hit quick trim this. Double click on this icon, trim icon, and you can trim it a lot of times. trim it, trim it, trim it, trim it, trim it. So this is the geometry of that is, and let's make chamfer corner. The corner is between this and this, just like this, with the radius of 3.3. For example, 3 make 3 corner, make it 3 to be uniform. No way. Make it 3. Make it 3. Or we can make this mirror to be uniform at this axis, and we will get this. We will trim this component, trim it, also trim. Then after, let's done this geometry just like this. Okay, nice. Let's say back and trim this section, trim, and make it 5. Make it 5. So this mirror with this point gives this. So double click on the trim icon, then trim it, and the geometry is look like this. This is not the correct. The correct is based on, this is not based on the standard. I take it for the tutorial purpose only, for the modeling purpose only. So this is the geometry of this sprocket. For example, let it 20 millimeter. Then the teeth of one sprocket, and make it this rectangular or the circular pattern with this circular pattern on the reference element in this surface. Then the number of these is 32. 32 is the number of these. So this is instance is 32. This is 360-degree one full circle divided by 32. It gives around 11.5 degree. Is uniformly distributed on the circle. So we make this circle. After that, we have to go now towards what we call our ring, and then this is 20, and make it, this is the 20. Okay, let's draw. This is the part of this circle is, this is the upper part, 82.05. 82.05. Make it 82.05. For example, draw. We can draw on both sides, but draw 82.05. 82.05 times 2 gives this, and we can make it, for example, 5 on both sides. On both sides. Eighty-two point zero five. 82.05 times 2 gives this, and extrude it. This is the dimension of the sprocket. Okay, the dimension of the dimension of the sprocket, and make it 50 for this. I'd like to make this dimension 39.5 r. This is 39.5 times 2 is the diameter. Make it from center 39.5 times 2. It accepts the multiplication in the algorithm. This and make it some sort of extrusion on this element. For example, this is around 40. Around 40. Make it 40. Then okay. Then we make it this chamfer, this part. Then make it fillet radius. Fillet radius of it is 10. Then okay. The plate is created now. Then the sprocket is appearing just like that. Okay, just like that. So now we are going to model the diameter of shaft is 22.05 radius. For example, this is the geometry. 22.05 radius. 22.05 times 2, it gives the diameter, and the hollow makes it pocket, and increase the dimension. We can increase the dimension or we can write it. This is the diameter of shaft, and construct the keyway. The keyway is just like this. Just to make it, we can write the dimension. We can write dimension based on the standard design, but this is for our modeling. This is for our modeling. For example, this is 20. Make it 20. You can make it 20. Double click by double click. And the height, we can also know the height, the depth of the for the depth on the gear of the key, and the depth on the depth of the key on the shaft, and the depth of the key on the gear. This is a rectangular sub key. So make it that, and bore it, and make it pocket. Then okay, the dimension the sprocket, and make it, for example, slide channel. Fillet. Make it fillet. For example, this part. 2. You can make it. A number of things, but this is more beautiful than this. So we can model the sprocket gear based on this. We can model based on the standard dimension of the gear for manufacturing, unless the gear and the chain will not match if you manufacture this gear, because this is without the correct design of the equipment, the sprocket gear. So when we make it fit with chain, it does not fit because I did it without the standard for the tutorial purpose only. I can model it, the sprocket gear, just like that. So make it file and save. Then you can select your folder or your position where my file is put, and desktop, and make it catia tutor and sprocket gear tutorial. and